All right. Welcome, everyone. Welcome to Polkadot Deep Dives. We have a special session for you today. We're going to be presenting the XCM Simulator and the XCM Emulator. And the presenters will be Frank Bell. He's right there, application engineer. And myself, Bruno. I'm a support engineer at Parachain. So we invite you to sit back and watch this good presentation. So the objective here, we're going to cover the simulator. What is the simulator? How to work with the simulator. So then we're going to do like a little demo, little deep dive on the simulator, look at some code. And then we're going to hand it off to Frank. And Frank's going to cover the emulator. What is the emulator? How is it different from the simulator? And how to work with the emulator. And Frank's going to do a nice deep dive into that. So the prerequisites, I would say you want to be familiar with XCM. So at this point, if you're working with a simulator, you should already know what the XCM instructions are. You should know what XCM is. You should be comfortable with the instructions. If you're not, here's some resources. Like the first one in the Polkadot wiki. There's actually a nice little wiki article on XCM. It's a starting point. You could start there. At the end, you can see there's some resources. And honestly, I recommend that you read all of them, especially the blog. And the other resource that I recommend is the XCM Format. It's a README inside of a GitHub repo. And it's really detailed, and it covers a lot of aspects of XCM, including like that it's asynchronous, it's absolute, asymmetric, and agnostic, right? And what does that all mean? And all the definitions, the vocabulary, what the instructions are, how the registers work, just like a ton of information. And lastly, but not least, we just came out with the XCM Doc. So a lot of you who are already in the ecosystem may not be familiar with this documentation. It's the XCM documentation. It just came out, so please read it. It's a wonderful read. I read it myself. It's very nice. It flows very nicely. So it's just a great read, and it covers a lot of different aspects. And we're actually going to use it today as we go about the XCM simulator. It's actually how do you say, like complementary to working with the simulator, at least to start out, right? To start learning the simulator. Okay, so those are three wonderful resources there. And a little bit of background on the simulator before we dive into it. So the simulator is actually a community contribution. You can see it right there in March 2021. There was this repo on the simulator by a community member. And in August 2021, the PR was created to add a simulator to Polkadot. So you can actually see the PR. I have it open here. I saved it. So this is the Polkadot repo, and this is the PR to add the simulator to Polkadot. And my favorite section, if you scroll down, there's a section here. Such a beautiful piece of code, right? So really nice to see community contributing useful and beautiful code. And the same community member went on later and added the emulator and opened a PR for the XCM emulator as well. Okay, so giving the credit where the credit deserves. So what is the XCM simulator? Let's talk about a few definitions. Let's cover a few definitions. So one definition, the XCM simulator, it's a tool to quickly test the execution of various XCM instructions against the XCM Executor. So just as a refresher, what is the executor? Right? If we look here, I have this tab open in the doc that I just described, and you can see there's a section here on the XCVM, right? The virtual machine, the XCM virtual machine. So like XCM, the XCVM is also a specification. So the virtual machine is a specification. The implementation that will be used in this documentation is the XCM Executor, right? So that's very interesting. So the XCM Executor is an implementation of the XCVM specification, right? So if we go back to that definition of XCM Simulator, it's a tool to quickly test the execution of various XCM instructions. You get to pick which instructions against the XCM Executor. Okay, so the executor is what will execute those instructions among other many different things that are specified in the XCVM specification. All right, and you can actually see in the repos, any repo that uses the simulator or that has XCM, like this one right here, we have the Cumulus Parachain template. If you go into the runtime and you go to the cargo.toml to look at the dependencies, you're going to see that in the XCM portion, it's right here, the XCM Executor, right? And what I want to show you is that it's getting pulled from the Polkadot repo, right? Just like the documentation said, right? So this is also using the implementation from Polkadot that's defined there, okay? So we're also going to be looking at this when we're using the simulator. So the simulator should be used as a playground, an XCM playground. And as we look at the demo, you're going to see like why it's a playground, and it's a useful playground, right? It's a playground where you can test different aspects of XCM, right? If you're wondering like, how does this instruction work? Like, okay, I read the code, I read the documentation, but I'd like to execute it without a lot of boilerplate code. Like just like put the instructions in there, execute it, and see what the results are. You can assert the results, right? So it's a good XCM playground. So setting up a network, a live network with multiple connected parachains for testing XCM is not straightforward, right? So you'd have to run a node, you'd have to, perhaps you want to test a relay chain with a parachain, or a relay chain or a parachain with another parachain, right? You got to run these nodes. It takes some time to get that going. If that's what that's the world we lived in before XCM Simulator, right? We'd have to spin up these nodes in order to test XCM. With the simulator, you don't need to do that. And you're going to see that you can define the parachains, the relay chain. You can define these mock parachains, these mock relay chains, right? And depending on your use case, this could be sufficient for what you're looking to test. All right. So let's look at one more definition. So the XCM simulator allows for testing XCMs fast, right? Because you don't need to spin up these nodes. You just create these mocks. And these are the mocks. You can use a mock for a relay chain and several different parachains. We're actually going to look at some of that code right now. So let's hop into the code here. So what I have open here is the XCM Docs. If you go to the XCM Docs, it's going to send you to, there's going to be a section in the XCM Docs that I just showed you that has the repo. It's actually the XCM Docs GitHub repo. So if you go there, it also has some examples, and that's what I have open here. And I'm going to make this a little bit larger. So you can see here, there's several examples. We're inside the examples folder. There's transfers, fees, transact, origins, holding modifiers, trap and claim, specs, queries, right? These are all XCM examples. So if I go back to the actual documentation that I showed you earlier, let's just go like here. Where is it? Here, right? Notice how on the left here of the XCM docs, we got similar like fee handling, transact, origin, more registers, right? So you can see how it's complementary, the docs with the examples here. So really, really nice read. As you're reading the docs, you can jump into the code and be like, okay, let me test that out. So that's how it was made. So Here we can see on the right-hand side, I'm going to collapse this for a second. We have the scenario here, right? Alice wants to teleport her native assets from the relay chain to parachain A. And there's this test, teleport fungible. We're resetting the mocknet. We're defining here withdrawal amount of 50 cents. And we're defining some extra parameters here in terms of fee. There's some functions we're calling. And then here we create a message, right? And you can see this message is a vector. And inside this vector, we have the XCM instructions. So withdrawal asset, we're withdrawing the withdrawal amount, 50 cents. And we're going to use that for by execution. And then we have an instruction called initiate teleport. And inside initiate teleport, one of the parameters is XCM. And in there, you can specify messages, additional instructions. And we have by execution and deposit asset, right? So that's what this message consists of right now. And you can see that this message is used down here. So right here, line 42, we're actually using the mock relay, right? And I'm going to show you that in a moment, like where is this defined, right? But we're actually using the mock relay and we're executing and we're saying, hey, let's make an assertion. Let's make sure that it's okay. The execution's okay. And we're saying relay chain XCM palette execute. What are we executing? Well, we're sending this, we're executing this message, right? And actually I almost said send. So like, that's a good recap also. It's like, why is this not a send, right? If we're doing teleport here, why is it an execute and not a send? So like, this could be like, that's why this is like a bit of a playground, right? So it's like, well, if we're teleporting, we should be sending tokens, right? But in here, I'm not seeing a send, I'm seeing an execute. So if you actually look at the initiate teleport, if I copy this, I think this is where it's like, okay, well, what is going to be executing this? The XCM Executor, right? So if we go, I think I have the tab here. We can go to the XCM Executor. Yeah. So I had this saved here. So I'm inside Polkadot XCM Executor source librs. And if you scroll down in this file at some point, I want to scroll up here just to show you, you're going to see a function called process instruction. And there's a nice comment, process a single XCM instruction. And if you scroll a little bit further, there's a match on the instruction, right? So if you continue scrolling, there's going to be each instruction, withdrawal asset that we're familiar with, transfer asset, transfer reserve asset, receive teleported asset, transact, right? So this is where it's like you can drop in here while you're working with the simulator and kind of refresh yourself, like what does the instruction do, right? If you really want to see the code aspect of it, right? There's you could go also to the XCM format and also read about some of these instructions. Initiate teleport, right? That's the one we're looking at. So initiate teleport, if we look in the code towards the bottom, right on line 667, look at that. It does a send. Okay, let me make that a little bit larger. So that when this instruction gets executed, eventually it does a send, right? So that's just wanted to point that out. That's very interesting, right? And it does a send and it includes the message. The other thing that I want to point out with this instruction, which is interesting, is that on this line here, we take the already existing, we take the message that was defined here, right? I don't know if you can see right there, receive teleported assets and clear origin, and we extend it by adding what was in XCM.0 there, right? So if we go back to our code, we have the initiate teleport, right? And then we have this XCM portion here. You can think of this as the XCM.0, right? Those additional instructions here, right? And that's going to make sense in 1 second once we cover the parachain aspect of this, when the parachain receives. So the relay chain executes it, right? We execute the v3 message. And then we do an assertion. So with XCM Simulator, you can do these tests, right? These assertions. So it's pretty powerful in that sense. And then now we have the Parachain A, and it's going to, before we cover this aspect, let's look at this right down here, right? We're going to do an assertion. We're going to check the message queue, and we're going to check that we have the expected message that was received, right? So if we look at that, it's defined up here on line 56, and it's a vector, and it includes receive teleported asset. All right, so it's gonna have a receive teleported asset. It's gonna have a clear origin, and it's also additionally going to have by execution and deposit asset, right? Because you want to deposit the asset, right? And then down here, there's the assertion to check, okay, does Alice's asset, whatever Alice has, does it include the withdrawal amount minus the fees, right? So we do that test. So you can see how Simulator is very, very powerful and very useful, and the extent that it goes to, right? What you can do with it. So just want to point out here, though, that this here and this here, right, this is the extended portion, right? So if you look back at the instruction that we were just looking at, there's the receive teleported asset, there's the clear origin, and then the extended, the by execution and deposit asset, that's the extended portion, right? That extend, okay? So that's all included when we send it originally. All right, so that's interesting to see. And then if you wanted to, you could take it a step further and look at the definition of receive teleported assets and what that instruction does, right? So when I'm just showing you my thinking process of like when I work with a simulator, like how I do it, right? It's sometimes I drop into the executor to look at like how it executes it, and then I come back here, right? So there's that nice play. So far, I mentioned that you can have a mock here of the relay, you can have a mock of the parachain, right? And I've mentioned that you could have several parachains. So in this repo, there's also a folder called Simple Testnet. This is the folder where we set up the test network, the mock test network. And if I open the mod.rs file there, you can see that it's really nicely organized. You know, we have some accounts, we have some balances, and then we have these declare, right? We have Parachain A, it's a struct. And you can see that we're specifying the runtime. So the runtime is actually specified in another file we'll take a look at. We're specifying the message handlers for Parachain A, right? The message queue, right? That's defined also in another file that we'll look at. And then you can specify another parachain. You can specify several parachains. You can specify a relay chain and the relay chain runtime and the XCM config of the relay chain, right? And then finally, you define your mock network, okay, as well as several other parameters. So let's take a look at, for example, like these parachain runtimes, right? Where are they defined? So there's another file in that folder called Parachain RS. And in there, you're going to see like a very familiar structure, right? Like this looks like a runtime, right? Here's frame system. We're familiar with that. And there's palette balances. So you can literally construct this parachain however way you want it, including the palettes that you'd like to include. Palette assets in this case. I believe there's also, palette uniques, right, for NFTs. So you're constructing your runtime here. You're defining your runtime. And remember we saw like that estimate weight, estimate fee for weight. Well, it's right here, right? So this is a great template, I'd say, like if you want to work with a simulator to study and to take a look at. You can see the barriers, right? The XCM barriers. That's pretty cool. And then let's also look at the relay chain. So relay chain RS is another file in there. And I just want to point out, like, here's the XCM config, right? So this is the XCM config for the relay chain. You can see the barriers there, the weigher, the trader, right? So if you're experimenting with the XCM configs, right? Or if you're even learning how to work with the XCM configs, you can play with a simulator and you can test different things out, right? And then you have palette XCM. And if I scroll all the way to the bottom right here, you can see the construct runtime and you can see all the palettes that we're using there, okay? So actually in the Parachain RS, if I scroll all the way to the bottom, there's some other interesting things like handle XCMP message, handle DMP messages, the mock message queue, right? So you can see it's using the XCM Executor. And the mock message queue, if I scroll all the way to the bottom, it's right there as a palette, right? So it's like a mock palette. So that might be something interesting to study as well, right? Because that's also used in the simulator and the tests. So I wanted to show you one more test. I think we're okay with time. There was this question in let me see, am I still on camera? Just to make sure. Yeah. Okay. So there was this question on Stack Exchange that I see this question come up every once in a while. You know, how do you verify that the XCM message went through successfully, right? Especially because one of the properties of XCM is that it's asymmetric, right? So asymmetric is kind of like you fire away and you don't, there's no guaranteed result, right? It's not like trustless. It's not permissionless in a way that's like, I'm going to send this message to this chain and this chain will reply, right? XCM was not built in that way. However, there are certain things that you can do that I will show you. So for example, there's these instructions. Let me make it larger. There's these instructions: report holding, query palette, report error, report transact status. All four of these instructions, they include a query response info struct. All right, and you can see that that's there. And the way that this works with the XCM Executor is that if the XCM Executor executes one of these instructions with the query response info, it will also have a corresponding query response that it will send back to the destination that was specified there, right? So in good faith, the chain that executes this instruction here, right? It'll so we're going to send this instruction, this XCM. We're going to send an XCM to some chain. Let's call it Parachain A. Parachain A will execute this instruction, and in good faith, if it has the XCM Executor that was specified with the specifications, the correct specifications, right? It will then it'll then send a corresponding query response to the chain that initially sent this instruction. Okay, so that's one way. That's a very useful way, and it's actually best practice. Like if you really want to know, like, did my transact succeed, right? So I actually there's actually in the XCM Docs repo, there's actually an example for this. So let's take a look at that. So it's exercise A8 queries. And the one that I would like to show you, it's the end, it's the last test, it's on line 179, and it's called report transact status. And the scenario here is that Parachain A wants to know if the execution of their transact instruction on the relay chain succeeded without errors, right? That's pretty good. That's a good use case. So they add the report transact status instruction to the XCM to get the status of the transact status register reported back. Okay, so we can see here, like if we look, we're going to be using transact. So we define here a call, and all this call is, it's a remark, and it's saying hello relay. That's the remark. So we define it there. We have some setup here, and then we have our message, and we have the instructions withdrawal asset by execution, transact, and inside of that transact, we can see that remark, right? That call that we have there. And so that's the transact, right? And following that transact, we include the report transact status instruction. And the way that you use it, you can see it's right there, right? That's the query response info struct that we just looked at, and the destination. So the destination here is Parachain 1, right? Why is it Parachain 1? Because the scenario is that Parachain A, which is Parachain 1, wants to know if the execution of the transact instruction worked on the relay chain, right? So Parachain A is going to send this message. So therefore, Parachain A, which is Parachain 1, is what goes in the destination, because the relay chain needs to know when it executes this, it's going to send a corresponding query response, not a query response info. It'll send a query response. It needs to know who to send it to, right? So we specify the multi-location right there. And there could be several query response infos, right? So that's why we have a query ID to tie it, a unique number there that we tie it to this specific query response info, to this specific report transact status, right? That's associated with all of this that we're doing. So Parachain A executes it. It does the send it, or I'm sorry, it sends it. It sends the XCM. There's the message. We're sending it. We're sending it to the parent. And then Parachain A is going to do an assertion, right? We're going to check the message queue. And in that message queue, we should see a query response, right? Because if we sent it to the relay chain is going to receive that message, which includes a report transact status. It's going to execute this against the XCM executor. When it reaches the report transact status, it's going to execute it, and then it's going to send back a query response. That's why in our message queue, we should see a query response struct with the matching query ID, and the response should be a success. Okay. If you want to learn more about query response info, and these, the report transact status and the other instructions that are similar, you can look at the XCM docs. There's some really good documentation on there for that. All right. So one thing that I haven't showed you, so like, oh my God, I can't believe I haven't showed you. So let's test this. Like I showed you the teleport earlier, right? This is the teleport. So we were teleporting, Alice teleports native assets from a relay chain to Parachain A. I think it was like 50, but there's going to be some deduction from the fees. So if I wanted to run this with a simulator, like in this repo specifically, all I have to say is cargo test, specify the package there, and the actual test, teleport fungible. And then you can see you can run it, and we get a success. Okay? So that's how simple it is, right? Once you have it all set up. If we go back to the queries, the report transact status, what is it called? Report transact status, right? I'm going to run this to test it out. Before I run it, though, I want to point out a couple of things. This here, I added this, okay? This is something, it'll print the events. So it's something that's actually defined if we look. Where is it? Right there. So inner mock test network, you can see that print pair events use Parachain system, and it's iterating through the events and it's printing them out, print LA. All right, so that can be pretty cool, right? Pretty useful for debugging if there's any events. So that's one thing that I added there manually that you can do as well as you're playing around with this. The other thing that, thanks to Frank, I learned this myself, is that you can include tracing. So this was something that I manually added to that. It's not in the repo. So if you want to add it, you're going to need that line of code right there. So tracing, you're going to see when I run the tests, like you saw the test that I just ran, right? That's it, right? It succeeded. You don't even know what happened. It's like, that's it. It's okay. Success, green, right? So with tracing, you're going to see every single little step, right? And this is super, super, super useful for debugging and for learning. So you're going to need that line of code. You're also going to need in the cargo.toml, you're going to need to include these two lines here, tracing and tracing subscriber. All right. And then you're also going to need to include some setup code in the librs file. So this code here from line 26 to line 36, this is the code that's needed to get the tracing to work. And you can see the tracing level is trace. And we also have some filter flags there. Okay. So with that, you can enable tracing in your simulator test by including that line. So let's run this. Remember what it's doing, right? It's going to transact. So I have it here and hit return and boom, right? You can see tracing gave you everything, right? So it succeeded. The test succeeded, but you can see XCM send XCM, execute XCM, right? Information about the weight, information about the barriers, right? Currency adapter, process instruction, right? And you can see all the details there, right? Ref time, proof size. So you get a lot of good information. And then finally, at the very end, this portion here, this is that print events line that I added as well. And you can see the event there, executed downward. Okay. And it succeeded. So if it didn't succeed, right, you could debug it. Okay. So that's it, everyone. Like that's the XCM simulator in a nutshell. The only other thing that I would like to show you is I want to point out, like, I don't know if you're all familiar, but Trappist is a parachain. It's live on Rococo. It's a good reference parachain. It's like, it's an example parachain, right? There's a lot of good best practices in there. And it has the XCM simulator in there. So I believe I have the repo here. Yeah, I just wanted to show you like a different setup. This is Trappist. Just to show you, like this is another place that if you want to see something a little bit more for the simulator, I'm inside the simulator source librs file. And you can see we're declaring a test parachain. Instead of calling it para A, we call it the asset reserve because that's what we're going to use it as. And you can see we're setting up some Genesis state here. And then we create another parachain here called Trappist, right? So this is another good place if you want to see like another, flavor of the simulator beyond just like para A and para B. And you can see there's also another file inside of the XCM simulator folder inside of Trappist that has the different tests. So there's some interesting tests here. You can see they're defined there. So that's also there if you want to study it and take a look at the different tests. And what's interesting too is that there's actually a workflow. So inside the Trappist repo, inside a .github folder, inside of workflows, you're going to see a simulate.yaml file. And it's actually a GitHub workflow that will kick off the simulator tests. Oh, there's Frank's name. Frank added the simulator. So yeah, so there's a GitHub action that will actually kick off the tests right here. So that's an interesting also idea that if for your project, right, if you're building a parachain, perhaps you want to have the GitHub action that runs these tests to make sure everything works. Okay, so that was something that I found interesting as well. So I believe that is everything that I wanted to share regarding the simulator. So last slide here is XCM Docs, right? The examples that I used, these are the code examples. You can find it in there. There's the repo. And the XCM Simulator, you can also see it inside of the Polkadot repo. The one that I showed you also is that there's inside of Trappist, and it's right there, okay? So I think that this is great starting points, right? Also for you to utilize it. And once again, it's a great playground to use. For more advanced cases, you'd want to go towards the emulator. Okay, so with that, I'm gonna transition here, and I'm gonna hand it off to Frank to cover the emulator. So thank you all.
Thanks, Bruno. Very detailed and a lot for me to maybe skip or build on. There are a lot of similarities between the two. So hopefully we'll just kind of touch on the differences just to kind of shed some light on it. So as Bruno mentioned, obviously the emulator allows you to do kind of more along the same lines, but rarely we looking to use sort of pre-configured runtimes. So you saw in the previous section that we're using mock runtimes, which are defined within the actual testing crate, testing library that's somebody's using to develop. Whereas now what we can do is we can actually pull in sort of runtimes that other projects might use from different parachains to different relay chains, etc. So a similar sort of approach, it allows us to test cross-chain message passing, verify the outcomes, weights, and side effects. But the nice thing here is essentially we're testing against sort of live runtimes. So sort of super useful. Just a note on the emulator, it's kind of similar to the simulator. It does use the transport layer palettes, but it doesn't use the same messaging infrastructure as live networks. So essentially you can imagine we've got a full node where everything normally would run on the outer node, will provide all the networking, etc. So we're just kind of mocking that out to kind of make it much more lightweight, so we can kind of iterate on it, test things out, test changes, make sure things work, debug, etc. So as a result, sort of things like consensus-related events are not going to be tested. We always sort of recommend that beyond the simulation and emulation, you still should be doing end-to-end tests, and we'll kind of touch on that very briefly towards the end. So just sort of very briefly, some pros and cons of the emulator. Some of these do apply for the simulator as well. So from my perspective, the best part of it is the debugging. So Bruno shows you the tracing. I'm hoping to show you a little bit of interactive debugging as well, and how you can kind of get right inside the sort of different parachain runtimes, or even down into the XCM Executor itself to kind of inspect what's going on, looking at holding registers, etc. I've also found in the past that it can be quite useful to see what's going on in EVM. So essentially, the EVM implementation is just kind of a substrate palette or Rust code. So once you pull that dependency in, you can set breakpoints there and actually figure out what's going on in the EVM as well as seeing outputs from the EVM in the actual debug console for the tracing. Another thing that's quite nice, I mean, again, likewise with the simulator, is that you get sort of composability. You can, if you want to integrate with particular parachain with particular functionality, you can just pull in that direct runtime. So essentially composing your solution with the different parachain services that you need. The next thing I think is really great is the instant feedback. So with your traditional end-to-end tests, you've got to build your nodes, fire up your sort of end-to-end testing framework, run the test to get some sort of response to say something's passed or failed. Whereas with everything being written in Rust tests, it's a much sort of tighter feedback loop, which is sort of great for test-driven developments. And then finally, sort of integration testing is sort of super neat. If a parachain that you may be integrating with releases a new version, you can essentially just create a new branch, pull in the new dependency of the new version, and then run your tests against that just to see if they've made any changes to their runtime, which could possibly break your solution. And then, just to be fair, looking at the cons, as we mentioned, it's only emulation, so you have to keep that in mind. Messages are always going to be delivered. There's no nodes involved. There's no networks involved. Dependency versions and patching can be a little bit tricky. So for example, some parachains, as an example, will use a forked version of Substrate, Cumulus, Polkadot, etc. So because everything gets compiled into like a single process and run, what that can make resolving those dependencies quite tricky at times. But luckily, there's the Rust patch feature. So in your cargo toml file, you can just add a little patch section and essentially override the dependency for that project to use the same dependency that you might be using for yours, say Substrate version, for example. The other thing to sort of keep in mind there is the simple fact of the Parachain project that forked a particular dependency may have some subtle change, which obviously then you would not be using. So something to obviously be mindful of. And then finally, compilation. You're compiling lots of different runtimes potentially with lots of different dependencies. So compilation can take a bit of time and take a bit of space. But I guess the counter to that is to say if you're doing your end-to-end testing anyway, you would need to compile the nodes in any case. So it's not that far off. So moving on then just to some of the components, and some of these were already sort of touched on by Bruno. So I'm not going to go into a huge amount of detail here, but the simple idea is, the more recent version of the XCM emulator that was added to Cumulus is actually Parody's sort of version of it, sort of inspired by the original XCM emulator version developed by Sean. So the main sort of change is that you can kind of declare your networks with a single macro call. And the reason behind that is essentially we have this concept of bridging, which is only available for Rococo, etc. test networks for now. But the idea there is essentially, we can kind of pull everything together with multiple networks, pass messages across, and kind of see how that's all working all within one process. Then it's specific again to the XCM emulator is there's a sort of nice addition of various different traits, which are kind of used by the macros to kind of pull all the different component parts together. And the main reason I'm just calling them out is because they kind of give a nice way to understand what's going on. And looking at each trait definition, you can kind of see how the things different items sort of plug together and essentially kind of inspire this diagram. So obviously we've got the network for defining a network with an optional bridge associated type. We've got the network components, which is essentially just a facade over the message queues, which are sort of held in memory. And then we've got all the other usual candidates like relay chains, parachains, bridges, and most importantly, our test externalities for actually running the tests. And then moving on slightly, the most important part is obviously the macros. I'm not going to cover those in details. The only difference really from the simulator is you can see it's networks plural, relay chains plural. So you can kind of, declare all your relay chains in one particular block. So it makes it just ever so slightly neater. And there's also the addition of the assert expected events helper macro. And then finally, as we saw with the simulator, we've got a sort of use case-based tests, which kind of just drives everything. So on that, I'm just going to now drop into a quick sort of code walkthrough and demo. So starting at sort of very high level, we're just going to show you how the networks are defined. So if I just drill into the actual definitions here, so you can see, we've got our test networks, and here we've defined a Polkadot, a Kusama, and a Rococo, different networks. And then likewise within Polkadot, we've the Polkadot mock network, we've then got the actual Polkadot definition. And you can see very similar sort of definition to the simulator. We have the sort of genesis function where we can define the genesis state. So obviously, because we're pulling in the runtime, like we would have a chain spec for launching a full node with the initial state of the chain, we can use this genesis function to define the initial state that is going to be used for our tests. So we just go back. So now you'll see that we've got the same runtime section, but when we actually look at the runtimes, we can then drill into, say, the Polkadot runtime, and we can see now that this runtime is actually now being loaded from the actual Polkadot runtime dependency. So if I go back here quickly and look at the cargo toml, you can see that, in contrast to the simulator where we had all the runtimes mocked within the actual project, we now have the actual runtimes that we want to be using. So here I've got Polkadot, Kusama, and Rococo runtimes being brought in for relay chain options. And then I've also got our Para A and Para B runtimes, which are just local to this project. Yeah. Then also another reference to what Bruno showed earlier. So he pointed out that the message queue there was mocked, but here you can see that the actual message queue is using the actual message queue on the runtime. So we'll kind of sort of cover the sort of networking message queue components shortly. So if I just go back there, then finally, sorry, we'll just show the definitions of the parachains. So we've got the same genesis, runtime, the actual runtime itself, which I can drill into, as you'd expect. Same normal runtime setup with defining all the palettes, etc. If I go back, I think that's pretty much owing to time that we should show there. So that was just kind of showing kind of the differences in how we define our network. Now we're just going to kind of quickly peek under the hood in terms of the XCM emulator. So the first thing was the traits that I mentioned. And really this is just so that you can kind of get a feel for the different things that are happening as they're used for the macros. So we've got a standard sort of testing externalities sort of set up there so we can run our tests. And then, as I mentioned, we've got the network trait with various different functions, but more importantly, we've got these message processing functions. So we've got the process message and then all the various sub message types within that: downward, horizontal, upward, bridged, etc. So that's just kind of sort of encapsulates what functionality is available on our particular network. So if I just go back. So that's kind of how the traits of a subsystem works, and then just briefly to show you the actual implementation of the macro itself, just to show you how all this sort of gets pieced together. So I'm just going to search for that and go to the definition. So this is the actual macro. I'm going to sort of gloss over a lot of it, but you can kind of see here that we're implementing that network trait that I just showed you. One of the functions is that we initialize it. And you can kind of see in the initialization function, we initialize all the different sort of message queues. So, we've got various different message queues depending on what's happening during the execution of our test. So that's the initialization. And then if we look at the process messages, you can see here that it's just a loop that will essentially continue to process until all the messages for the test have been sort of delivered to their destinations and all the XCM has kind of worked how it's supposed to have worked. And then within that message processing, you can again see that we're processing upward, horizontal, downward, and bridged. And then if we just briefly have a look at one of those, so a downward message would be from a relay chain down to a parachain. And if we look into it here, you can just kind of see that it's kind of looking at the downward messages queue, matching those messages to the destination parachains that are available on that particular network. And then once it's sort of sorted those or deduplicated them, it's then going to deliver those messages to the actual parachain itself. So it's kind of taking them from one portion of memory, one queue, and moving them into another queue, where that is then passed into the actual parachain itself, the parachain runtime, which will then process those messages. So I'm not going to go through the rest of them, but they all kind of follow a similar sort of setup. And then finally, just to conclude under the hood of the emulator, so if we have a look here, we've got these threadlocal definitions. So these are kind of where the actual message queues are defined. So with it being threadlocal, sort of each test run being on its own thread, each of these sort of data structures will exist for the duration of that test, isolated from any other test running on a different thread. But more importantly, you can kind of see that for each different classification or message type, we've got a hash map, and that hash map is keyed by the network name, because obviously we could have multiple networks with bridges. And then the value of that is essentially the queue that's going to be holding the messages. And then we also track other additional information by network, depending on what processing is happening at the time. So that's kind of just a sort of quick summary of, have all the sort of smaller components. We're now going to look at a very simple use case. So this is just using a palette from Cumulus, and all it's going to be doing is it's going to be sending a ping from parachain A to parachain B. If it's successful, parachain B with the same ping palettes is then going to send a Pong response back to parachain A. So kind of a very simplistic version of the example that Bruno showed about using the query response info, additional functionality that was added in XCMV3, I believe. So if we kind of quickly have a look at the test. So firstly, I'll just run the test as Bruno did before. And you'll see that the sort of the first line is that we have our tracing again. There we go. And obviously it fails. But kind of what I wanted to point out is that because of that tracing, we can kind of see, why it's failed. So we can see it's gone through various barriers, but it's kind of ended up that the barrier blocked execution. The error was process message error unsupported, and the origin of this particular message was coming from Parachain 2000, which is Parachain A. So, the first thing we can do now is to try and start sort of debugging that. So if we debug it, and this is the part that gets interesting for me, is because we have all the code being compiled into a single process, we can have breakpoints, and the good thing about that is we can kind of see exactly what's going on at each sort of step along the way. So the first breakpoint is in the send function on the ping palette, and we're just kind of breaking here because we want to look at the actual XCM that's being sent. So just to contrast this to the ones that Bruno showed, where we normally have withdrawal assets and by execution, this one is just doing a transact. And here, because it's, this particular palette was just used for test spamming or spamming test networks, we're not really concerned about the weights here. So I'm just going to skip to the next breakpoints. In sending it, it inserts a ping into storage, just to kind of keep track of it. You'll see now that the next one we've hit is in the barrier. So this barrier that it's kind of hit is obviously now in the destination chain, so Parachain B, and this is the allow top level paid execution barrier. But you can see here that obviously we're only allowing these types of instructions, and because the message that we're sending doesn't have that instruction, we should then get a failure. So I'm going to skip over that, and you can kind of see there we'll get a Rust panic. So obviously I know the cause for this. So what I'm going to do now is go about fixing it. So a quick and easy way, and obviously not necessarily recommended for production parachains, but just for the sake of this very simple demo, is to say that currently runtime B on Parachain B is not accepting any messages where there's no unpaid execution. So what we're going to do is we're going to allow unpaid execution from Parachain A, and then debug our test again. Good opportunity to have a sip of water. So we should see a kind of a few of the initial breakpoints that we saw initially, which I'll just kind of sort of skip through. But more importantly, because now we've changed the barrier, we should get a little bit further in this sort of use case. So now you can see that we can get past the barrier. That's okay. We're returning okay. So the barrier has led that through. And now you can kind of see that we've essentially dropped into the XCM Executor. So as Bruno showed before, we're in the process instruction function within the executor. And then if we continue one more, oh, sorry, wrong one, debug, next one. We're now within the actual transact handler of the match for the particular instruction. So the nice thing with this is that you can kind of see exactly what's going on. You can kind of see what the call was, what the instruction is, what the weight was that was requested. So you recall those 1000s, but also you can kind of inspect all the registers that are available in the XCVM, what the current status is. So this is sort of super useful and super powerful to see exactly why something's failing. End-to-end tests, for example, a lot of this will be sort of quite opaque, where you can't actually sort of dig in and see what's going on. So it kind of helps you to kind of figure out what's wrong much quicker. So we'll just sort of continue this execution. You can see now that it's led us through. It's calling the ping function on Parachain B. So it's allowed us to call that function, or dispatchable function rather. And then what's happening here is in that ping function on destination, on Parachain B, we're then going to send a pong, which is there, call pong, back to the source parachain, which is sent from there. So back to Parachain A, just to essentially confirm it. So ping pong. And I'm just going to skip through all those, and you'll see that we've got another panic. Now, the reason for that is exactly the same as the first one, whereby Parachain A is not allowing any unpaid execution from Parachain B. So we'll just apply the same fix, change that there, and then this will be the last compilation, I promise. So now we have a passing test. We can kind of just inspect the output of that particular test, and then just to kind of show, we've got the ping, we've got the events being outputted, we've got all the XCM traces. We can kind of see that the first portion of it is the send from Parachain A to Parachain B. Parachain B processes it through all these different barriers, all the different steps. We then receive the ping. We then send the pong back, and then we've got all the XCM messages, which are then going to be obviously when this gets executed back on Parachain A when it's receiving the response. And then finally, we've got the pong received and all the sort of instructions processed, etc. So I'll stop there. We're running out of time. Let me just quickly move on to the final slide. It's just to basically mention that the integration testing that we've shown through simulator and emulator, you can kind of think of it as sort of like a runtime integration testing, but it's not sort of full node. It's not full end-to-end integration testing. So it's super important that anything you do with these emulation or simulator tests does get followed up with end-to-end testing, and there are a lot of great tools available for that. Obviously, ZombieNet, the Parachain integrations test, which uses ZombieNet as well as I think a few other ones, as well as Chopsticks. So I think we just made it on time. Have we got any questions? Okay, no questions. All right, I think we made it with 6 seconds to go. So thank you very much, and have a good weekend, everybody. See you.